Okay. Hi, I'm James King. Doing a presentation with Matteo and Shebu here. Just a bit of an update on trusted firmware. Bit of an update on where we are with the open source, open governance project. That's the communities division project. Talk about what's been going on in terms of the two main components, TFA and TFM. And then we've actually got a small celebration, you may have noticed. So we were hoping to actually announce the trustedfirmware.org Linaro Communities Division project starting this week. We're a few weeks late. I mentioned this in some other meeting this week already. But it should be happening sometime within the next month, hopefully. Pretty much everything's in place to be able to go. The website is there and available now, but what's more important, over the last 5 months since Connect, the code drop down, the dashboard, the wiki drop down will all have links to actual useful information about the project, where you get the software, what you can do to collaborate, and how the project works. And so going to there and clicking on the code, you get to Git repositories that have got the TFA and the TFM code in. This code has been evolving on, which we'll talk about in a moment. Probably more interesting to a lot of people is we're starting to fill out the wiki pages and the documentation pages, in particular with roadmap information, where we're going, what we're planning to do, and make sure that this is actually run as a fully open project with certainly ARMS plans made available to anyone who wants to be able to see it fully publicly. I'm not going to talk through the details here. And so, as I say, the project almost at full kickoff. Everything is, all of the infrastructure is working. We just need to get to the point where we actually do a press announcement and start the first board meetings. For those people who are signed up, and there are a few people signed up, they obviously include ARM and Linaro, but there's Google and Cypress and Data.io and some other people that I can't quite mention today. Those people will certainly be able to start influencing the roadmap, getting their preferred systems into the CI framework, which is actually being discussed this week, I believe, in one of the talks, and worked on in the hacking room, and start to help direct where we're going with the project and what we want to be able to do in terms of supporting trusted software and trusted frameworks elsewhere. And I think quite importantly, because it's the trusted firmware for the A class and for the M class, we just want to reiterate, this is firmware that's applicable to all of the ARM SoC market segments. There is almost no product that has an ARM CPU in that actually shouldn't be considering their threat models. And so we're still very interested in anybody else who's interested to join from other segments and or have questions and input on the project. Cool, at which point I'm going to pass over to Matteo.
Thank you, James. Just see. All right. So hi everyone, I'm Matteo Carlini and I'm the Senior Technology Manager for Trusted Firmware A for the A class. So I own the roadmap of Trusted Firmware A. I'm going to give you an update on the latest news about the project. But before that, I would like you to take a step back, actually a step back 5 years ago, a long time ago. So I'm not sure if you can hear it, but it was October 25th of the 2013 when Trusted Firmware finally became an open source project with the 0.2 release. So ARM had an idea of creating a runtime firmware a way back. The idea was supporting ARM v8 evolution and deployment, and also trying to defragment the firmware space for ARM processors. So the idea was beginning of 2013, it was discussed during the year. There was a first release, 0.1, that was a binary release only, part of a Linaro ARch64 release. And then finally, with that commit, it became an open source project on GitHub. It was announced at the LCU 2013 Linaro Connect. And since then, there was a history of 5 years of success. A few highlights of these 5 years. So 1.0 release in 2014 included a Juno port and integration with OPT. The 1.1 release included the very famous PSCI specification support, so the power state coordination interface, very popular, and an initial integration of the trusted board boot specification. The 1.2 release completed the TBBI implementation and started to see support for various platforms coming from partners. 1.3 release added a 32-bit PSCI support, and more importantly, in 2016, we finally dropped the CLA, and now we are accepting all the contribution under DCO, very simply. 1.4 dynamic shared unit support, a bunch of other ARM IP support, the high keyboards, and then we are almost there, March this year, 1.5. We are embracing a lot of other market segments, for example, with the RAS story and with the secure partition story. We are adding support for a dynamic configuration feature, and Linaro added support also for ARM v7. So we are now here, almost there, October. Trusted Firmware is becoming open governance, and we are almost ready with the 1.6 2.0 release, and we will migrate quite soon, actually, it's going to happen, into the Linaro Community Division TrustedFirmware.org project. So let's have a look at some numbers, historical numbers from the project. In 5 years, we have roughly 6,000 commits, and here is the split between ARM and partners commit. That's okay. I would say it's not really fabulous, but if we see the evolution over the years, because the initial pie is overall, but if we see the evolution over the last years, so in 2015, we had only 6% of commits coming from partners. That more than doubled in a year, almost doubled again in 2017, and now we have more than 1/3 of commits coming from partners. So one may argue, well, that could be because ARM decreased its effort into the project, so ARM is committing less. Well, that's not entirely true. If we see the number of commits coming from partners over the year, it's increasing a lot, and in the last few years, we had almost 400% of increase in just 2 years. So overall numbers, we have 25 companies contributing, more than 20 partner boards supported. That this number doesn't count ARM platforms, so counting ARM platform, this will become more than 30 boards supported upstream. And there has been also a huge increase in the last months. So in the last 3 months, we added 5 new platform support coming from partners. We are covering, as James was saying, all the market segment for ARM v8A. So mobile, clamshell, automotive, networking, edge, server, embedded, you name it. There have been 10 official releases of the project. And in terms of conferences, so we are always here in Linaro Connect, more than 10 presentations. There have been 5 appearances at the UEFI Plug Fest presenting the project. And recently, actually last week, there has been an open source firmware conference in Germany in which Trusted Firmware was there with 2 presentations, one from ARM and one from Google. And I recently wrote a blog post that is in there on trustedfirmware.org. So we are now approaching the 1.6 and 2.0 release. This will be a big jump. So the 1.6 release will include a lot of new features that are listed there. So very quickly, we'll complete the RAS support with 8.4 features and 8.2 features coming in. We are continuously developing the story around secure partitions. Secure partitions is a way for isolating and executing multiple software in the secure world in an isolated and protected environment. We are adding the latest workarounds for the Spectre Variant 4 issue that includes both static and dynamic mitigation into the firmware. We are adding support for a bunch of new ARM cores and for a few architectural features like the 8.4 MPAM in the firmware. We are continuing our effort in cleaning up the project against a Coverity MISRA tool non-compliances that we found on the project. That's an ongoing effort that we are doing since beginning of the year, really. We are improving our story on the dynamic configuration. That's the possibility for having a firmware binary blob that's configured externally via some configuration files that can provide additional inputs to the firmware in order to run the same firmware on different boards, on different SoCs. A bunch of new hardware support, as I said, and this is mostly covering the 1.6 release. Then what will happen is that just after the 1.6 release, we will get rid of some of the old stuff that we accumulated over the years, mostly deprecated APIs that are already marked as deprecated in the code base. We just get rid of them, and we will move to the 2.0 release that will be the baseline for all the subsequent development as we move into the trustedfirmware.org project. So now have a look at the future, briefly, what we expect to happen in the next 5 years from now. So first of all, we are disclosing our internal test suite because we have been asked, okay, what do you do for internally testing your firmware? So we are now preparing an external release of our internal test suite that will be a baseline for progressing and maybe contributing by our partners to the test framework. We will continue the evolution of the secure partition story. There is still a lot to be done. So we still have to enable multiple EL0 partitions in order to run management services or UEFI runtime services in the secure world. And then we will start to enable the SecuriL2 story. That's an ARM 8.4 extension. So this will eventually allow multiple trusted execution environments to coexist in the secure world. So possibly having multiple trusted OSs that runs in parallel in the secure world, with a secure hypervisor running underneath. We will obviously continue to enable ARM IPs, ARM specification, and architecture evolution. We aim to publicly announce a more regular release cadence. There will be an end-to-end story around security that embrace not only secure boot or concepts like measure boots, but also a secure firmware update, an over-the-air update, why not, an in-band, an out-of-band update. So all of these concepts will possibly come in the next future. Security assessment and threat modeling, it's another big topic. And then continuous integration, board file. So why don't we can think about trustedfirmwareci.org? That could be maybe interesting from someone. And then finally, one little vision. No, that's not the flux capacitor, as Doc Emmett Brown would say. The possibility of having one single code line of the firmware, maybe one major release that is deployed across different boards, different partners, and with different features. So think about the Linux kernel. So why the firmware shouldn't be the next kernel, having major releases, LTS releases, and so on. That's still a vision, but something to look after for the future. So all of that to say, why don't you join us to make the project even more successful? And having said that, I'll pass the microphone to Shibu.
Hi, everyone. I'm Shibu. I'm the technology manager for Trusted Firmware M. I own the roadmap for Trusted Firmware M. So I'd like to take some time in this part of the presentation to give you a brief overview about Trusted Firmware M, the journey so far in the last 6 months, and how TFM would look like in the future. So TFM was officially launched 6 months back at Hong Kong. It's quite at its early stages, and we believe it's going to be one of the foundational block in securing the trillion connected devices in the next 1 or 2 decades. And George just reminded us on Monday how important security is going to be in those trillion connected devices. In a very simplistic term, TFM is providing a trusted execution environment for ARM v7 and V8M devices. And this is where it basically differs from TFA, where it's providing a trusted execution environment for A-class devices. Of course, it leverages the trust zone that comes available with V8M platforms. In terms of services, what it basically provides is a very secure boot functionality and a bunch of secure runtime services like cryptography, secure storage, audit logs, attestation, all those good things that you would expect in an IoT-like device. We are building it with the idea that it's highly configurable, because we know that in the IoT space, you will have a wide spectrum of use cases where people would want to pick and choose the services they want. They might want to insert new services. So it's being built in a very configurable way that it can be used in a wide variety of use cases. And one of the important aspects of TFM is it's all being built around as a reference implementation of ARM platform security architecture. So ARM PSA was announced towards the end of 2017 at TechCon. And here, ARM is trying to have a holistic approach towards security and starting off with IoT devices. And there are 3 fundamental functional blocks if you look at PSA. It starts off with something we call as security modeling and threat analysis. So it's basically looking at a system, trying to identify the threat models, what are the assets to protect, and finally coming up with a set of security requirements to have a secure system. ARM has publicly put out certain use cases related to IoT devices where it has done threat modeling and come up with some of the security requirements. The second aspect of PSA is a set of hardware and firmware specifications, which you can consider as a toolkit or a checklist for SoC designers when they're designing a secure system. And the third aspect of PSA is what it ties up with Trusted Firmware M, where it defines an open source firmware implementation, which basically complies to the firmware and hardware specifications. At the same time, tries to address the threat models that the first stage defines. So as I said, the first stage, the outputs are sort of public. It wouldn't be long before all these PSA specifications are going to be publicly announced, and there are going to be more interesting aspects that you'd see coming up around PSA, around compliance and things like that. So that was a brief overview about TFM. It's basically providing a trusted execution environment around V8 and V7M devices. Now, I was trying to think about how to put up the short journey that we were having around TFM. And I think back at Hong Kong, it was more of a newborn baby with less clarity on how it would look like. And I think over the last 6 months, there has been a lot of development, and I think now it's can be called an infant, where it has sort of started crawling around, it has started becoming a bit mischievous, so it can start doing useful things as of now. And we truly hope over the next few months and running into early 2019, it will become a toddler who is really, really mischievous. It can do very useful things, and it can go into real production systems. So that's the vision. So let's look at how did the newborn baby look like. So this is sort of a functional block diagram for how TFM would look like in a V8M system, where you have got a non-secure side, you can have your operating system and your non-secure applications. TFM is basically the bolded route line, and back at Hong Kong, what we had was a very initial TFM core implementation, which is responsible for the communication, interaction, and management of TFM. And we had a very early stage secure boot, which is based on MCU boot open source project. And in terms of runtime services, we had a secure storage, which was still in its early stages. It had pre-compiled policy access tables, single key operations, and things like that. If you look at what we have upstream 6 months down the line, we have got the TFM core, which now supports the IPC, which PSA defines. It has got a more full-fledged secure partition manager. There has been enhancements to secure boot to handle multiple images. Some of it is upstream, some of it is in active review. In terms of secure runtime services, we have now got audit logs, which is basically a service that TFM provides to other secure services to log some of its critical events. In terms of crypto, we've got the initial set of APIs. We are currently reviewing the actual service itself. It's going to be upstream on the master branch in the coming days. And PSA API is one of the fundamental building blocks of TFM, where it's exposing a standard set of APIs which the non-secure site applications can call in to get hold of these secure services. So corresponding to these services, now there are these PSA APIs upstream. So that's what I was saying, that now it has become more of an infant, where it can do more useful things around cryptography, secure storage, and audit logging. So let's look at how it will be becoming a toddler, becoming more useful. So we are working on interrupt handling, so that should come online early Q4. In terms of services, crypto would be well integrated with the non-secure side, so that should be more fully functional. Attestation is another big activity that's happening within the project. So we are embracing EAT, which is Entity Attestation Token, which is something IETF and global platforms is trying to standardize on. So the attestation claims will be wrapped around the EAT specified way of CBOR and COSI signing. Provisioning, still in the early stages. There are two aspects to it, factory provisioning and the life cycle management. Those are, I would say, still in the early stages, so that would be coming online probably early 2019. Platform, it's providing a bunch of platform services using the hardware that is underneath. And there will be provisions so that it would be very easy for people to add their own services as they see fit. Then at the moment, what is more solid is the level 1 isolation, which isolates the non-secure and secure side. There is work ongoing to have the next 2 levels of isolation. So we hope towards the end of the year, early 2019, there should be level 2 isolation, which basically isolates the more secure privileged domain with the less privileged secure domain. There should be a set of platform drivers, which is basically a set of APIs which calls into hardware accelerators, whether it's around cryptography or things like that. So that should be coming online late Q4, early 2019. TBSA-M is one aspect of PSA, where PSA is telling these are the minimum set of hardware requirements that you have to fulfill to become a PSA compliant devices. So we would be trying to standardize on some HAL APIs around TBSA-M, so it becomes easier for partners to adopt or embrace those APIs. So I think this is how the Toddler would look like roughly, very roughly, sometime in 2019. But we appreciate that being an open source project in IoT, where it's all about open source, it's not good enough to just focus on the growth of the kid, not just on feature development. So we have been also looking at how we make it easier for all of you to embrace TFM and see TFM working on real platforms. So we've got TFM now ported on some of ARM's IoT reference platforms. So Musca is the actual silicon platform, and we've got some reference design that runs on the FPGA MPS2 platform. So if you go to trustedfirmware.org TFM project, you should be able to get the platform ports for these two platforms. And there is active work going on within the ARM partner community to port TFM into some of their V8M devices. The other aspect is how can TFM become the secure counterpart of some of the popular RTOSs. So there is active work going on to integrate the secure boot and the runtime secure services in TFM as they become available into these OSs. So Embed OS should have TFM supported on Musca A in Q4. As you know, the Light team is actively working on integrating TFM, again on Musca A, on Sapphire. So there is a pull request that's active, so you should have Sapphire and a minimum integration of TFM on Musca. The FreeRTOS integration is also actively happening, so you should see TFM working with some of these RTOSs very well in the coming days. More than that, as James was saying, we are trying to make it a truly open source project, which means all our designs, code reviews, roadmaps, it's all public. There is nothing being done secretively within ARM. It's all out in the public, whether it's the get it reviews or the design documents. So we would encourage all of the partnership to go have a look. If you have comments, please do raise tickets or a get it review, and we will definitely take it very positively, and we would very much appreciate that. So just to wrap it up, I think TFM comes with a lot of benefits to the ARM ecosystem and to the wider trillion connected devices story here. So it makes it less costly to have a IoT secure system because you're having a secure standardized firmware with a standard set of APIs. It would be easier to integrate with software applications, and above all, security can be scaled only through these sort of open source projects where if there is another instance of a Spectre meltdown, you fix it on a few devices, the fixes gets spread across a wide variety of devices because it's all based on one open source code base. So we see very much the journey happening very actively. So back in Hong Kong, the project just had 43 commits on its Git. Now it's sort of 175. We are racing fast so we can get better numbers than Matteo. We are starting to have support for GCC. There's a lot of ecosystem engagements. Throughout 2019, we should see more and more secure services coming online, integration with RTOSs, and more platform support in the project. So I would say be part of the journey, and we would very much appreciate all your efforts to make TFM great. Pass it on to James.
Okay, and just one thing to try and point out, actually we talk about these as two separate trusted firmware projects, but the goal of a single trusted firmware code line in the long term is still absolutely inherent here. It's just that the different segments are working at slightly different paces, but we will try and get there. If you haven't noticed, ARM trusted firmware, 5 years old, as Matteo said, and we've got a small celebration. There's some drinks and some cake at the back. We'd like you to join us in celebrating. Just before we do, if anybody has any questions, happy to field them between any of us, or we will just go and have a drink and some cake. I did it that way round on purpose. You can ask your questions in private over a drink. I'll take that as a, yeah, if you can pour the drinks out, that'd be great. Thank you all very much.